On a frigid December morning in northern Maine, Eleanor Blackwood Stevens loads about 40 pounds of dry cordwood into the firebox of her masonry heater, lights a single match, and walks away. 2 hours later, the fire has burned out completely. The massive stone structure has absorbed tremendous thermal energy through its internal flue network, and now that heat radiates gently into the home for the next 22 hours, maintaining comfortable temperatures without any additional fires, fuel additions, or system attention. That single fire provides all the heating her home requires for a full 24-hour period, even as outdoor temperatures plunge to 20 below zero Fahrenheit. This is the masonry heater, a building tradition refined across 600 years of European development that achieves heating performance contemporary wood stoves cannot match, while burning 70 to 80% less wood than conventional stoves heating equivalent spaces. The approach uses substantial masonry mass to absorb intense heat from brief high-temperature fires, then radiate that stored energy gradually across extended periods. The heating pattern produces comfort exceeding what any other wood-burning approach achieves, while essentially eliminating the air quality problems that have made wood heating controversial in contemporary contexts. Understanding how masonry heaters work, what their construction involves, and where they fit contemporary residential heating helps explain why a growing community of cold-climate homeowners considers this ancient technology one of the best heating solutions available for homes with reliable wood supply. The fundamental physics of masonry heater operation combine intense combustion with massive thermal storage in ways that produce superior heating performance. The combustion chamber fires burn at high temperatures exceeding 2,000 degrees Fahrenheit, achieving complete combustion that extracts virtually all available chemical energy from the fuel. The hot exhaust gases route through an extensive internal flue network that transfers heat efficiently into surrounding masonry mass. The massive masonry structure, typically 4,000 to 8,000 pounds for typical residential installations, absorbs the heat and stores it across long periods. The exhaust exits the heater at relatively low temperatures, typically 200 to 400 degrees Fahrenheit, after most heat has transferred into the thermal mass. The stored heat then radiates into living spaces gradually across the subsequent 20 to 24 hours until the next fire. The traditional European designs that inform contemporary masonry heaters include distinctive regional variations reflecting local materials, climates, and cultural preferences. German Kachelofen designs feature decorative tile exteriors around brick masonry cores. Finnish Kakalugni designs emphasize practical construction with less decorative elaboration. Russian Pechka designs often incorporate integrated sleeping platforms providing night heating. Austrian, Swedish, and other regional variants each bring distinctive features while sharing the core principle of brief, intense combustion, followed by extended thermal mass heating. Contemporary masonry heater designs draw on this rich traditional heritage while incorporating modern combustion engineering refinements. Dr. Wilhelm Schumacher-Klein, a German mechanical engineer who has specialized in masonry heater combustion research for over 25 years, has documented how contemporary masonry heaters achieve combustion efficiency exceeding 90%, while producing emissions substantially below conventional wood stoves. His research at German technical institutions has contributed to European emission standards that masonry heaters routinely exceed. The research findings demonstrate that the approach delivers genuinely superior performance on objective measures rather than just subjective comfort claims. The technical documentation provides evidence-based foundation for continued adoption and code recognition in various jurisdictions. The construction process for masonry heaters requires substantial skilled labor from craftspeople experienced with the specific techniques that effective construction demands. Professional masonry heater builders typically require 2 to 4 weeks to construct typical residential installations, working from detailed plans that specify combustion chamber dimensions, flue routing, and thermal mass configurations. The construction uses specialized fire brick for combustion chambers, standard clay brick or stone for thermal mass structures, and specific mortars formulated for the high temperatures that different zones experience. The specialized requirements mean that general masons without masonry heater experience typically cannot construct reliable installations without substantial training or collaboration with experienced builders. Ingeborg Mustonen Johansson, a Finnish masonry heater builder who has constructed over 200 heaters across 30 years of professional practice, has documented how construction quality directly determines long-term performance and durability. Her experience shows that properly constructed heaters deliver 100-plus-year service lives, while poorly constructed examples may develop problems within a decade. The quality sensitivity supports using experienced builders whose track records demonstrate competent construction rather than accepting lowest bids from general masons without specific masonry heater experience. Her training programs have contributed to developing builder networks in regions where masonry heater expertise was previously limited. The thermal mass sizing considerations for masonry heaters depend on specific heating loads and operational schedules. Typical residential installations use 4,000 to 8,000 pounds of masonry mass designed to support single daily fires maintaining home temperatures across 24 hours. Smaller installations for smaller homes or supplemental heating use less mass. Larger installations for larger homes or regions with severe winter conditions use more mass. The sizing calculations require experienced design because inadequate mass produces uneven heating patterns while excessive mass extends response times unnecessarily. Proper sizing matches specific applications to available masonry mass. Now for the obstacles and limitations affecting masonry heater adoption. First, the construction costs substantially exceed conventional wood stove installations. Typical masonry heater construction ranges from $10,000 to $25,000 for residential installations, compared to $3,000 to $6,000 for good quality conventional wood stove installations. The cost premium reflects the substantial materials, skilled labor, and design sophistication that masonry heater construction requires. The premium investment delivers operational benefits across decades, but requires substantial upfront capital that not all projects can accommodate. Second, the floor loading requirements exceed what typical residential construction supports. Masonry heater installations typically require reinforced concrete slabs or substantial structural modifications to support the substantial weight. Existing homes retrofitting masonry heaters face particular structural challenges that may require foundation work beyond the heater installation itself. New construction integration is substantially simpler when structural provisions can be planned during initial foundation work. Third, the space requirements for masonry heater installations exceed what conventional stoves occupy. Typical heaters require 6 by 8 feet or larger floor space plus clearances to combustible materials. The substantial footprint affects home floor plans and may not accommodate easily in all residential configurations. Strategic placement in central locations maximizes heating distribution while minimizing space impact on preferred room layouts. Fourth, the chimney requirements differ from conventional wood stove chimneys. Masonry heaters require properly designed masonry chimneys or approved metal chimney systems capable of handling the high temperatures that intense combustion produces. Chimney installation costs add to overall project budgets while requiring coordination with masonry heater design. The chimney considerations affect overall project feasibility, particularly in retrofit applications to existing homes without suitable existing chimneys. Fifth, the code approval complications in many jurisdictions require masonry heater installations to follow alternative methods procedures rather than straightforward certified product compliance. The Masonry Heater Association has developed standards and certification programs that increasingly streamline approval processes, but many jurisdictions still require project-specific engineering analysis. The code complications add project costs and time while potentially discouraging some interested builders. Despite these considerations, masonry heaters represent exceptional heating technology that delivers remarkable combination of comfort, efficiency, and sustainability for appropriate applications. The operational characteristics of masonry heaters produce comfort exceeding what any other heating approach achieves. The consistent radiant heating across 24-hour periods eliminates the temperature swings conventional stoves create. The absence of forced air distribution prevents dust, circulation, and air movement that occupants sometimes find uncomfortable. The gentle radiant heat warms occupants directly through infrared radiation at comfortable levels rather than heating surrounding air that must then warm occupants through convection. The comfort advantages consistently motivate continued enthusiasm from owners who experience masonry heater operation compared to conventional alternatives. Jun Tanaka Sasaki, a Japanese architect who integrated masonry heaters into contemporary Japanese residential projects, has documented how Japanese aesthetic traditions adapt beautifully to masonry heater integration. His projects demonstrate that masonry heaters can serve as architectural centerpieces that enhance home beauty while providing superior heating function. The aesthetic integration extends masonry heater application beyond the European traditional contexts where the technology developed, supporting adoption in diverse cultural contexts where skilled masonry traditions exist. The Japanese applications demonstrate universal appeal of the approach across cultural boundaries. The fuel efficiency advantages of masonry heaters produce dramatic wood consumption reductions compared to conventional stoves. Typical masonry heater installations burn 1 to 2 cords of wood annually for primary heating, compared to 4 to 8 cords for conventional stoves heating equivalent homes. The consumption reductions translate directly into reduced labor for wood gathering, reduced forest impacts, and dramatically reduced emissions across the heating season. For homeowners gathering their own wood, the labor savings alone justify the investment premium. For homeowners purchasing cordwood, the fuel cost savings produce substantial annual benefits that accumulate substantially across decades of operation. The emissions performance of masonry heaters addresses air quality concerns that constrain wood heating acceptance in many regions. The complete combustion that brief, intense fires achieve produces particulate emissions 80 to 95% below conventional wood stove emissions. The clean emissions enable wood heating in contexts where conventional stove emissions would be problematic for air quality or neighborhood compatibility. The emissions advantages particularly matter in regions where air quality regulations affect wood heating adoption. Some jurisdictions provide specific permits or incentives for masonry heaters in recognition of their superior emissions performance. Luisa Fernandez Torrejon, a Spanish environmental engineer who has measured emissions from diverse wood heating appliances, has published comparative data showing that well-constructed masonry heaters produce emission profiles comparable to natural gas heating while using renewable fuel from sustainable forestry operations. Her measurements provide evidence that wood heating need not entail the air quality compromises that conventional stoves create. The environmental performance supports continued regulatory recognition and expansion of applications in regions where wood heating might otherwise face restrictions. The durability of properly constructed masonry heaters across multiple generations of use demonstrates exceptional long-term value. Traditional European examples operating for 100 to 200 years demonstrate extraordinary service lives unmatched by any alternative heating technology. Contemporary installations using proper materials and construction approaches typically carry manufacturer guarantees of 25 to 50 years, with expected service lives matching or exceeding historical examples. The multi-generational durability transforms investment economics by spreading capital costs across extended operational periods that alternative heating technologies cannot match. The integration of masonry heaters with domestic hot water production creates particularly valuable combined systems in some installations. Heat exchangers integrated into flue gas paths can extract heat for domestic water heating, while primary heating function continues unchanged. The combined heating and hot water production extracts even more value from the wood fuel, while reducing the need for separate water heating systems. The integration complexity requires more sophisticated designs but delivers substantial additional value for households interested in comprehensive sustainable living. Alexander Ponomarenko-Savchenko, a Ukrainian-American masonry heater designer who has developed integrated heating and hot water systems for cold climate homes, has documented how combined systems produce exceptional total energy performance. His projects show how thoughtful integration extracts maximum value from each fire while providing comprehensive thermal needs through a single system. The integrated approach requires sophisticated design but delivers exceptional overall performance that fragmented alternative systems cannot match. His published plans support interested builders in replicating similar integrated approaches in their own projects. The cultural significance of masonry heaters within the homes that feature them extends beyond pure function. The impressive visual presence of substantial masonry structures typically becomes a defining feature of the homes they heat. Families gather around masonry heaters during winter evenings, appreciating their radiant warmth while using heater surfaces as seating or display surfaces. The cultural role that heaters play in family life contributes meaningfully to quality of life beyond just heating function. Owner testimonials consistently emphasize these cultural dimensions alongside the technical advantages that drove initial purchase decisions. The community and educational infrastructure supporting masonry heater adoption has matured substantially in recent decades. The Masonry Heater Association maintains builder directories, design standards, and educational resources. Workshops across North America teach construction techniques. Published resources document design approaches and construction details. The community support enables motivated homeowners and builders to access the expertise that successful masonry heater projects require despite the technology's relative obscurity in mainstream construction. The climate applicability for masonry heater technology favors cold climates with substantial winter heating requirements. Moderate climates with brief winters may not justify the substantial investment that masonry heater construction requires. Hot climates with minimal heating needs don't suit the technology at all. The climate matching supports appropriate application decisions rather than universal recommendation regardless of conditions. Cold climate rural contexts with abundant wood supply represent ideal applications where the technology delivers exceptional value. The distinction between traditional European masonry heaters and American Russian fireplace designs deserves clarification since both approaches share principles while differing in specific configurations. Russian fireplaces use similar thermal mass heating principles, but typically in more compact configurations with different flue routing approaches. European masonry heater designs tend toward larger installations with more decorative treatments reflecting traditions where aesthetic presentation has been as important as heating function. Both approaches deliver similar technical performance while suiting different project contexts and preferences. Contemporary builders draw on both traditions while adapting designs to specific project requirements rather than slavishly copying any single historical precedent. Valentina Rodriguez Herrera, a Spanish-American masonry heater builder who has worked across the western United States for 18 years, has documented how regional material availability and climate conditions affect optimal design choices. Her projects in Colorado, New Mexico, and Utah adapt European design principles to regional soapstone, granite, and native clay materials rather than importing specific European materials that would substantially increase costs. The regional adaptations maintain core performance advantages while producing construction economics compatible with American residential building budgets. The adaptation approach expands accessibility while preserving the essential technical characteristics that make masonry heaters effective. The financing considerations for masonry heater installations in new construction can substantially improve investment economics by incorporating heater costs into building mortgages. The multi-decade payment of construction mortgages spreads the substantial upfront costs across long periods that match the extended operational lifespans of masonry heaters. Retrofit installations to existing homes face more challenging financing, since home equity loans or personal financing typically involve shorter terms and higher interest rates. The financing differential supports new construction integration as particularly economically favorable application timing. The specific material selections for masonry heater construction affect both performance and long-term durability substantially. Soapstone has become particularly popular for contemporary masonry heater exteriors due to its exceptional thermal mass characteristics, durability at high temperatures, and attractive appearance. Firebrick specifically rated for severe thermal cycling in combustion chamber. Applications differs from standard firebrick in subtle but important ways. High-temperature refractory mortars designed for the extreme conditions in flue passages differ from standard masonry mortars. The specialized material selections add to construction costs but substantially improve long-term performance and service life. Contemporary best practice specifications emphasize these material quality considerations even when they increase initial project costs beyond what budget-focused approaches might prioritize. The operational learning curve for masonry heater operation requires some adaptation from users accustomed to conventional stove operation. Loading the firebox with adequate fuel for complete heating cycles, using appropriate dry fuel for clean combustion, controlling draft during fire development, and scheduling fires to match daily heating needs all require practice to optimize. Most new owners develop proficiency within a single heating season, though some users benefit from operational guidance from experienced masonry heater users or the builders who constructed their installations. The learning investment rewards development with optimal heating performance, achieving the full potential that the technology offers. Masami Takahashi Kimura, a Japanese-Swiss masonry heater educator who has taught operation classes to hundreds of new owners across 15 years, has documented how structured operational training substantially improves user satisfaction and performance outcomes compared to simply leaving new owners to discover operational approaches independently. Her training programs cover fuel selection, fire management, scheduling optimization, and troubleshooting approaches that address common operational questions. The educational investments produce measurable improvements in owner satisfaction and reduced complaints about initial operational difficulties. The training approach has contributed to expanded adoption by addressing the operational complexity that otherwise discouraged potential adopters. The integration of masonry heaters with contemporary passive house construction combines exceptional building envelope performance with efficient wood heating to produce remarkably sustainable overall performance. The superior envelope of passive house construction substantially reduces total heating loads, enabling smaller masonry heater installations to fully meet heating needs. The brief daily fires of masonry heaters provide both heating and modest fresh air exchange through combustion air requirements. The integrated approach produces homes meeting stringent passive house performance targets while using renewable biomass fuel rather than grid-supplied energy. Several demonstration projects have shown this integration producing net zero or near net zero total energy performance while providing exceptional comfort and resilience. The research on historical European masonry heater examples provides insight into the extraordinary durability that properly constructed installations can achieve. Operating heaters from the 1600s, 1700s, and 1800s survive across Europe in ongoing use, demonstrating multi-century service lives with appropriate maintenance. These examples provide evidence for the long-term value proposition that justifies substantial initial investment, showing that heaters constructed today could reasonably be expected to serve homes for 150 years or more. Few investments in contemporary building deliver comparable multi-generational service lives, making masonry heaters distinctive in their long-term durability characteristics. The contemporary product development in the masonry heater sector has produced kit-based systems that simplify construction while maintaining traditional performance characteristics. Precast core systems provide the critical combustion and flue components as engineered products while allowing custom exterior finishes that match specific project aesthetics. The kit approach reduces construction labor and improves consistency compared to pure custom construction while preserving design flexibility for external appearance. These products have expanded market accessibility by reducing both cost and skilled labor requirements compared to traditional full custom construction approaches. Consider what masonry heater technology means for cold climate homes with reliable wood supply committed to long-term heating solutions. The remarkable fuel efficiency of 70 to 80% reduction compared to conventional wood stoves produces substantial environmental and practical benefits. The superior comfort through continuous radiant heating exceeds what any alternative approach delivers. The exceptional durability across multiple generations transforms investment economics through extended service lives. The clean emissions performance addresses air quality concerns while enabling wood heating in diverse contexts. The cultural and aesthetic contributions enhance home quality beyond pure function. The integration with hot water production extracts maximum value from wood fuel. The community support infrastructure enables successful projects despite the technology's specialized requirements. The question isn't whether masonry heaters deserve consideration for appropriate applications. The question is why the remarkable performance of this proven technology remains so little known compared to far less effective wood heating alternatives. The answers involve unfamiliarity, substantial upfront investment requirements, and specialized construction needs rather than fundamental limitations of the approach. For cold climate homeowners with reliable wood supply, adequate budgets, and commitment to long-term thinking, masonry heaters offer exceptional heating solution that delivers benefits conventional alternatives simply cannot match.